Chapter 8, Periodic Properties of the Elements. I skipped 8.1. Don't remember why, but I did. There we go. 8.2. Dmitri Mendeleev, often given credit as being the father of the modern periodic table. So he ordered elements by atomic mass and observed repeating properties. We've talked about this. When the atomic mass order didn't fit with the other properties, he went by the other properties. An example of this is tellurium and iodine. They are out of mass order. He didn't know what protons were, but he still got the order correct. He was able to predict that missing elements would be discovered, and he even predicted their properties, and it's pretty amazing. I mean, this guy he died in 1907, right? It's a long time ago. So he predicted that an element below aluminum would be found. He called it eka aluminum. Eka is just a prefix that means below. So below aluminum, now we know this as gallium. His prediction, atomic mass about 68 atomic mass units, actual mass 69.72, pretty close. Low melting point, yep, got a low melting point, it'll melt in your hand. Density, 5.9. He predicted the density is 5.90. Nailed it. Predicted the formulas of the oxide and of the chloride compounds it would make. He also predicted ecosilicon, which we now know as germanium. Again, very accurate with his prediction, based on the properties of the elements around those missing elements in the periodic table. There are a lot of patterns, a lot of information in the periodic table. In quantum mechanics, looking at what these electrons are doing explains why those patterns are the way they are. The periodic law says what's going to happen. It allows us to predict properties, but it doesn't explain why those patterns exist, but quantum mechanics says.